Great, so let's go to the second one, CMAF HAM. HAM means hypothetical application model, and also is the thing that goes in the middle of the bread. But our bread is HLS and Dash, so let's explore that. Yeah. Alex, in fact, this is literally after JP made the presentation at the IMAX, I said, hey, I have an idea, And okay, he told us that, hey, we have this issue. Currently, we are, as you know, as industry, we are a lot of time creating Dash and HLS, but just changing sometime from creating from a HLS video, creating the Dash version, or from HLS the Dash. And also, we are a lot of time doing some, you know, the manifest manipulation. Remove a track, or for example, fix some issue with a language that was, you know, the language in a track or whatever, because it's malformed or whatever. And Alex said, hey, when CMAF as the standard came out, nobody paid attention or more attention to this particular chapter, that is the CMAF hypothetical application model. And this can help us to do this job better. The CMAF hypothetical application model describes, in a logical way, it describes a logical model to describe the content that you are going to send. But it is it doesn't describe the manifest level. It should say it will have some way to say a player that you're going to have some revisions, adaptation suites, different things that the player should take or show to the user. But the good thing about this logical model is that it's just it's something that you can think that can work for HLS, can work for Dash, can work, for example, maybe in the future for media over quick also. And the idea is that this part of the standard says, okay, the presentation part, the way you are going to show the player what to play or what are the choices, it's a logical model that we can use for all the standards. Also, for example, in this case, we can create some, for example, we can say, okay, in the CMAF model, we have something that is called presentation, but look, in Dash, that is called a period. And in HLS, it's called also presentation. Or a different, another is like a track. In the CMAF logical model, a track, it's in Dash, it's called representation, and in HLS, it's just the media playlist we're used to work with. So the idea is, why don't we work with that side to create this side? That's the main idea of the library. And that's why I say this is the hub, you know, the two breads over there. And so to create this, the idea was to create a library, a proof of concept of a library to work on this. And to work with this, also we had to learn a lot of stuff from 4 different specifications or specs. Of course, CMAF, Dash HLS interoperability spec. That's a great spec that says how to convert things. And of course, the HLS spec and the Dash spec. When we started the project, we say, great, this is a great idea. So let's create, let's split this into different stages. First stage, let's define the scope of this proof of concept in 4 meetings, and then go to develop everything that we just defined previously. And creating a scope of work with something we want to cover and also. And, yes. After we finished, I think it was 3 meetings or the 4 meetings. I said, okay, we don't have anything. We don't understand. Looks like there is the problem is more complicated as we expected. And so we created very fast and created a working group. So we said, okay, let's meet every Friday to talk about how are we going to do this. And the scope of what we do is to create just in the whole month, meet all Fridays, work in open points with defining questions like, we need to solve this, we need to solve this, we need to solve this, and just go to those meetings to talk about how are we going to to solve those issues. And of course, agree all together the best implementation. And also, this was a parallel like what the team was working, and also bring some insights from the team that was working in the library to, to say, okay, what you described, this is the best solution. It's very difficult to implement and things like that. And also, oh, sorry, and I think I want to share to you with, the results of the working group. Of course, we agreed with all the issues we have, all the open issues, and it was great. We worked on 14 open issues, open points. We agreed on all of those. And we also have a list of learnings and things to continue working up to the proof of concept. Because the proof of concept, again, I think one of a proof of concept in my perspective has two outputs: the code itself or the proof of what you want to do, and the learnings to know how to continue with the project. Also, we have 18 participants, and it was crazy, it was great, from 7 different organizations. And that's very cool because we had inputs from people that is working also or have real problems with this. So for me, bring knowledge from different organizations, again, it's like it goes with the spirit of the summer camp. We are collaborating to create a bigger thing. So for me, that was my goal, to be honest. So thank you for that. And something we did internally also, because we realized we didn't know CMAF, is to create a study group inside Collabs. And so a lot of you, Collabers, joined this. We had 8 sessions with 12 participants to learn about the standard, discuss things we didn't understand and whatever, with the main goal to create proposals to the meetings with everyone. And I think this was hidden stuff here, like not a lot of people know about that, but I think it was a great idea to create some kind of study group inside Collabs, and I want to do something with this. So great, let's go with the learnings and results. Let's come with this.
Okay, thanks, Nico. Well, hello to everyone. I'm Matthias, and I will show something from CMAF HAM team. Well, before going to a quick demo of the work done, I want to share some of the diagrams of the architecture in a high level, just to understand better than when I go to the demo. Well, first, when a developer interacts with the library, we'll see some methods. The 4 important ones are those that are for mapping manifest to HAM and HAM to desired manifest. And also there we have 2 important types that are the presentation and the manifest. So let's go to the presentation. Well, the presentation is the HAM object. Okay, so it's a tree. We know where the node, the root of the node is presentation, in the segments are the leaves. This is the object where is converted every manifest that are the input to the library. So if a manifest goes to the library, it's converted to this object. And then the other object is the manifest. This is something that we introduced to the library for better manipulation of the input in our library. One of the reasons is because in MPD, in Dash, you have one single file for a content, but in HLS, you could have many manifests for each playlist. So there we have, I don't know if you can read that, but it says ancillary manifest. It's an optional attribute where you can hold the playlist for HLS base. And this is the internal implementation of the library where the mappings are happening. We introduced here the strategy pattern. We have an interface with 2 methods, from manifest to HAM, and then to manifest that receives the HAM object. And then we have the complete implementations of that strategy, of course, MPD mapper and HLS mapper. And then we have the mapper context, which has the actual instance of the strategy. And also it's a singleton because we want just one single instance of that context. And if you want to add more mappers in the future, you can just add a new implementation of that interface without modifying the interface, the mapper context, or other places in the code where the mapper context is being used. So this is the full view, how all is connected, what I already explained in the previous slides. So now I want to go to the demo. So sorry. Okay, let me share the screen. Maybe who is, oh, okay, it's already in, right? Yeah. Okay, nice. Well, so if I am a developer, of course I am. I can
Hypothetically.
I can import the library as it. Here are the 4 methods that I already showed, that are the most important ones. And I want to share a piece of code that I have here. I will show the dash example, okay? So first, I'm reading the file, the input file, to get the data, the content as a string, to then use the library. So first, I want to show what the input is. This is the manifest, which has 2 tracks, one for video and one for audio. It's a video of 50 seconds. And I have a player to watch the video. So it's the common Big Bunny video. Okay, yeah, I can go in the timeline. Well, you already know. So, well, here I'm taking that data, that string, and sending to the library using npd to ham function. Here I will receive the ham object. And one optional step that you could do here is to validate something. In the meetings that we have, we talk about validating the presentation in some way. In this case, we implemented the tracks validation that we are using here. And then if the validation status is okay, I proceed to just convert to NPD and HLS that you see here. Okay, so this is just an optional step that I wanted to show you, but you can just send the ham presentation to the map and you will get something. If it's not valid, you will not be able to see the content. Okay, so let's run this code. Okay, in the logs, I put some logs for the validation. The validation right now is just checking that all the tracks have at least one segment, and all the tracks have the same duration. So was okay. So I know that the output happened. But before going to the NPD output, I want to show you how the ham object is. So here I have the ham object with all the information from the NPD. So here is represented as JSON also. That's something interesting because you could do some operations in the object and then converting into a desired format of manifest. So there are the things, the video track, the audio track. So now I will show the dash output, comparing with the input. So in the left side, you are seeing the input file, and the right side, the output file. As you can see, they are very similar. Of course, we are using some attributes in the middle, but it's very similar, and also the output is playable, sorry. So I want to show that also. Here I have a player that is reproducing the output. And it's working. I can navigate into the timeline. So what we know now is that the output is playable. We are losing some attributes that we know that as known issues. We need to continue working on that, of course. And also here I put the conversion to HLS, and I will show you how the output is. Is this playlist, let's say? We know that this is not working today. It's something baseline to continue working on, because here, for example, the URL is wrong. It's putting the meme type. And also there are some missing attributes. In this case, the conversion from MPD to HLS is not playable, but we have something to continue working on. Okay, so that's all I have to show in the demo. Any questions? Okay. Question of the demo?
Are you guys considering also adding in validation of Dash prior to converting it to the presentation, and same with HLS? And there's Dash validators, there's HLS validators as well, so that it's all centralized in one core foundation.
Yeah, we thought about that. We didn't find yet TypeScript validation. Some project we can use.
Yeah.
The most typical is the Dash if validator that is made in PHP.
Yeah. And HLS
So
is command.
Something to add to the common media library.
Right.
Yes, please.
Actually, I think that's a perfect place for it.
Yes.
Get the common media library, and then we can
Yes.
utilize it elsewhere.
So I think we also saw that there are a lot of course, there are parsers over there because players need parsers, but there are no writers. So, and we noticed that there are no writers in TypeScript open source of this. So we had to create that. We also thought that we could start looking at how to bring, the readers from players that are also needed in the common media library and use them to also like parse the content using already proved parsers. I think those are the kind of learnings we want to cover and understand and say, okay, we have opportunities here. We need to implement things here also, and continue like a create a roadmap after all the learnings we got.
And how are you guys planning on tackling HLS segments that need to be explicitly defined from a Dash manifest that has this and that?
There are a lot of issues.
I'm not sure if you guys have any cool ideas yet. Like that's a tricky one, right?
Yeah, we have to limit our scope for this POC to,
Right.
Only support addressing modes that we could essentially deduce from the manifest.
Cool.
And I think long-term solution is that if we want to support all the addressing limits, we're going to have to start parsing the segments. We're going to have to start actually cracking those open and looking at the headers. And, which is totally feasible and totally acceptable, but it's just out of scope for this POC.
And please don't take my question. I'm excited. I'm like, ooh, I want more.
Yeah.
Not negate the hard work you guys put in, which looks excellent. I just want to see this keep going further.
Nice. Okay, let's go with some accomplishments. Some goals met. We have a functional proof of concept. I already showed the case of Dash, but we also have a use case with HLS, converting HLS to CAM and CAM to HLS, and it's playable also the output. We have the mapping, of course, and also we get the first playable output. So those are the accomplishments. Now the most important part, I think, is the learnings. Well, first, Dash versus HLS. We already talked about that a lot here, but both formats can get complex the more you dive in. When understanding deeper each format, more use cases appear to be considered. For example, in Dash, we have 3 ways to represent the segments, and also the configurations can be written in different ways, but the same configuration. That's something crazy. The manifest metadata. There are some metadata in the manifest that today doesn't have representation in the HAM object, and also it's not the responsibility of the HAM object to hold that information. For example, in Dash we have content string settings, CMCD settings, before a PO. So those all of those metadata we are storing in optional attribute in the manifest object that I already showed. Just to have one implementation in the POC, but the idea is to continue going forward from there. Patterns, theory versus practice. Okay, a good architecture is not achieved by using complex solutions, but by simplifying complex problems, right? So we consider some patterns in the initial stage of the project that made a lot of sense in that stage in theory, but then going to the practice, we noticed that those patterns added more complexity to the project. So we had to stop, spend some time thinking, rethinking the solution, rethinking the problem, making a document comparing each patterns, and make a decision. So we came to the conclusion that the strategy pattern that I already showed was the most suitable option for this project. And also, we managed to solve two problems at once, mapping from HAM to manifest and from manifest to HAM. Well, with the 4th point, dual track. We worked in 2 tracks in parallel, as Nick already said, discovery and delivery. The discovery, of course, was the most important one, where all the meetings happens, the decisions, the discussions. And also in the delivery, we get the POC, but that is something that we are also using in the discovery track, because now we are learning from the POC. That is a truth, because now that we have something working, we know more issues, we know more things to cover, so we are really going into tracks, and that's something that we learned that for using this project was very a nice idea to use. Well, what are the next steps? First, showcase the work done to the community and share the learnings and decisions, and also be open to the suggestions, for then collaborate and define a roadmap for next work. Okay, so that's all I have to mention in my part.
Thank you. And one more thing. That's very fun. I always wanted to do that. So part of people work here working with Impala said, hey, I really like this project. I want to do something with this. And someone say, hey, I want a user interface for this library. And someone created some of this, and I want to show you. I want to show you.
Oh.
Please.
Okay, so hi, I'm Constanza. Yeah, we have been working on something else. Well, we kind of work in a second proof of concept, and we built a web page to show kind of the real value and the potential of the CMAF HAM library. And well, for that we built a web page. And well, the idea with that is to create like a tool to show how the library works, and most important, what things we can do with it. And also, like thinking of the future, we could also see this new project as a potential demo app to showcase the application and the CMAF HAM. So Santi here is going to share the screen and show you what we did.
So the screen. So let me refresh this. This will just testing out. So here, this will be like a brief explanation of what we can do with the application, as Betty said, with the library. Sorry. First of all, I'll start by importing a dash file. In this case, I will be using the same manifest that Mati was using, this dash sample MPD, which contains 2 tracks. Once we load this, we can see this ham model represented visually. As you can see, it has 2 tracks, one for video, one for audio. We try to maintain the representation of the model to be as similar as possible to the CMAF spec document that Nico showed before. So well, here you can see the different selection sets, switching sets, and inside the tracks. We could click a track, for example, and see information about this track. A good thing to have in the future, we have the edit button here, but it doesn't really do anything. It would be good to, for example, be able to edit this information, stuff maybe like, I don't know, the language of the track, or probably not the duration, but stuff like this. Maybe the name, then be able to do some other manifest manipulation things, removing tracks, for example. So we can exit off from here, and sorry, I was showing this. We could also finally export to HLS, which I think is like one of the most rich features that this library offers, which is, well, I input this dash manifest and export it as HLS. So here we download this as a zip. As you can see, I already have it downloaded. Let me open it, and as you can see here, there is a track for each, sorry, for a playlist for each track, and also a playlist for the main presentation. And yes, this is about it. Thank you very much.
Thank you. Well, we are reaching the end. No more surprises. Well, overall results. 23 contributors. That's a lot of people. That's a lot of people. 7 organizations around, the people who work for different organizations. So a lot of knowledge, sharing a lot of knowledge. We worked on 2 projects, and 3, in fact, because the UI could be considered one. Yeah. We added 2 new features in the Multimedia library, 3 pull requests to players, and some are done now, and Casey is taking a look at those. And yeah, we created the proof of concept. So that was great. A big applause. The last thing, we printed some tiny posters here that we want the external contributors to, to bring to your home. And everyone who has contributed here, please sign this. I think it will be like a great present for, having been in this crazy, idea of summer projects and summer camp. So again, thank you very much. We need more ideas for next year. Thank you.